Okay, so on this unit, we're going to do something that we've been doing ever since second grade, third, fourth, fifth. We're just going to go ahead and add negatives and positives to it, and we've done this last year as well. So I'm going to go over the adding rational numbers rule, and we're going to take our integer operations rule in order to figure this out. So the thing you need to remember about adding rational numbers, now those rational numbers could be either negative or positive, so there are two rules in which you must remember. Rule number one, if they are the same sign, then just add regularly and keep the same signs. So same sign, add and keep sign. Okay, so simply put, 2 plus 5 is going to be equal to 7, all right? It's the same size, same sign, positive and positive. A positive and a positive will give you a positive. Next, adding negatives. Negative plus a negative will just give me a negative. So this will be -6, okay? I add, I keep the same signs, okay? Now, things are a little bit different when you add with different signs. So say I have a -5 and I'm going to add a +2. In that case, I'm going to subtract and keep the sign of the higher absolute value. So 5 minus 2 is equal to 3. The absolute value of 5 is 5, if -5 is 5, and the absolute value of 2 is 2. So 5 is bigger than 2, so we have to keep that negative sign, okay? That's basically the rule. Signs are different, you subtract, keep the sign of the higher absolute value. When signs are the same, you just add them up and keep the same signs, okay? Now, let's go ahead and let's put these examples here. So 2 plus 5 is equal to 7. -2 plus -4 is equal to -6. And then -5 plus 2 equals -3. So I'm just going to keep those there so that you'll understand the pattern. Now, let's get into decimals. So let's say I have 2.8 plus a -3.64. So there's a few things that we have to keep in mind here. I have to first figure out, are signs the same or are signs different? I have a positive here and I have a negative here. So signs will be different. So I'll be following this rule. I'll be following the subtraction rule. So I'm going to say 3.64 minus 2.8. And keep in mind, I'm lining my decimal places up. So I'm going to go ahead and subtract that. So that's 4, 2, this is going to be 8, and then this is going to be 0. So my answer is going to be 0.84, but since 3.64 has a higher absolute value than 2.8, my answer is going to be -0.84. Okay? Now, let's go ahead and try something else. That's decimals. Let's take a look at fractions. So I have 1/4 plus, let's say, 2/3. Now, the rule about fractions is you cannot add or subtract if the denominators are not the same. As you can see, my denominators here are different. So, I know that 4 could go into 12 and 3 could go into 12. 4 times 3 is 12. So, I'm going to rewrite this, but with denominators of 12. Okay? So, to get from 4 to 12, I had to multiply by 3. So I multiply the numerator by 3. 1 times 3 is going to be equal to 3. So 1/4 and 3/12 are equivalent. They are the same. All right? Now, 3 times what number equals 12? Times 4 times 4. 4 times 2 is equal to 8. These are equivalent. They are the same. Now that my denominators are the same, I could go ahead and add. 8 plus 3 is going to be equal to 11. So my final answer will be 11/12. Okay? Now, let's go ahead and take those rules and look at some different signs. So, let's say we had 3/5 plus a negative, let's say 2/9. Okay? So, the first thing I have to do is make sure my denominators are the same. I know that 5 and 9 have the number 45 in common. So my common denominator is going to be equal to 45. So times 9, this is 27. Okay? And then I have to remember that this is a negative here. Then times 5 times 5. So that's 45. and this is 10. My denominators are the same, which is perfect. This is exactly what I need. Now, if we look at it, I have a positive number and I'm gonna add a negative number. Now, which rule is that? Is that same sign rule or different sign rule? That's a different sign rule, so I have to subtract. So 27 minus 10 is gonna be equal to 17. And then 45, the denominator is the same. So my answer is gonna be 17 over 45. I can't really do much. It can't be simplified, so this will be my final answer. Let's go ahead and try one more, but let's try a mixed number. Negative 2 and 1/3. Let's keep these numbers simple. Negative 2 and 1/3, and I'm going to go ahead and add, let's say, 4/9. Okay? So here I have a mixed number, so I have to actually do something different first. I'm going to go ahead and convert this into an improper fraction by multiplying 3 times 2 and adding 7. 3 times 2 is 6, plus 1 is 7. So I have negative 7 over 3, and I'm going to add that to 4/9. 4/9. Okay? Now, from here on out, I do the same thing. I go ahead and find the common denominator. It looks like 3 and 9 could both go into 27. Okay? So, times 9, this is a negative. 9 times 7 is 63. Times 3 times 3, this is going to be equal to 12. Okay? So, at this point, signs are different. I have a negative and a positive, so when signs are different, I need to subtract. So I'm going to go ahead and do this off to the side. 63 minus 12, 1, 5. My answer is going to be 51 over 27. But I have to remember, this has a higher absolute value than this. 63 is bigger than 12, so my sign has to be negative. Okay? And that's how I go with adding rational numbers.